Hello, everybody. I'm Mr. DeLong, and today we'll be talking about nuclear fusion. So, what is nuclear fusion? Well, Merriam-Webster says that nuclear fusion is the union of atomic nuclei to form heavier nuclei, resulting in the release of enormous quantities of energy when certain light elements unite. Translating that to English, it's two small atoms creating a bigger one and producing energy in the process. Where in our universe does fusion take place? Well, fusion produces the energy of the universe. The core of our sun is made up of tiny hydrogen atoms colliding and forming helium. The energy created becomes the light that we see and the heat that we feel. Without fusion, there would be no life on Earth. Atoms are constantly moving, and their speed is tied to how hot they are. Within the sun's core, it is about 27 million degrees Fahrenheit. So these hydrogen atoms that are zipping around the sun are moving so fast that when two of them slam into each other, they become one atom, despite them being pushed away by their magnetic charges. It's like putting two magnets together. When the atoms are the same charge, they push away from each other. If you push really hard, you can make them touch, but they still come apart if you let go. These atoms are going so fast that they become one. When these atoms slam together, a little bit of their main body, their mass, escapes. But the whole bunch of energy is released from this. I'm sure everyone has seen Einstein's famous formula E equals mc squared. Well, this is what it describes. A tiny bit of mass lost times the speed of light squared is equal to a whole bunch of energy. And this energy is what's produced by nuclear fusion. In our sun, over 600 million tons of hydrogen becomes helium every second. Imagine that amount of energy. Now, we ask, how does fusion work on our planet? Well, in laboratories, we take a different approach since we have to work with Earth's gravity and atmospheres. Things get a little tricky. We have found the easiest atoms to fuse with the lowest temperatures while producing the highest amount of energy. Now, these temperatures are still really high, about 10 times hotter than the core of the sun, but we're able to work with that using heavy machinery. So, we take two different types of hydrogen. We'll call them hydrogen D and hydrogen T. We fuse these together and produce helium, and as a byproduct, we get a humongous amount of energy. But how do we use that energy? Well, when the atoms collide, a little bit of the mass that is launched off super fast gets absorbed by the walls of the reactor. This energy heats up water that is surrounding the walls, and this water produces steam. When the steam spins turbines that make energy that we can use. Now that we understand how fusion takes place within our solar system and on Earth, let's talk about why we want to do it. Why would we choose fusion over other energy sources? Well, there are a few reasons. We have a whole bunch of hydrogen D and hydrogen T, and it doesn't cost much to get. It's generally safe to perform. The nuclear waste made by the reaction is so much less than other nuclear reactions while lasting a lot shorter of a time. It doesn't produce greenhouse gases that hurt our environment. And finally, fusion is about 4 million times more effective than burning coal or gas. Nuclear fusion is in the progress of being researched. We don't know when we'll see it, but right now we're able to turn 10 bits of power into 100, and companies are working day in and day out to make fusion a part of our daily lives. Thank you all for watching. Happy holidays.